Hi students, now we are going to discuss about the topic on 8251 programmable communication interface. So 8251 IC 8251 is called as programmable communication interface, or also it is called as serial communication interface, that is IC 8251, IC 8251 or IC 8251A. So it has another name that is called as USART, that is Universal Synchronous Asynchronous Receiver Transmitter, that is nothing but as USART. So actually basically the microprocessor can communicate with the other systems using the two different types of communication interface. So they are parallel communication interface and then serial communication interface. For parallel communication interface, the IC is called as 8255. For serial, the IC is 8251. So in this video we are going to see about the IC 8251 introduction, and then the IC pin diagram, the block diagram of 8251, and then what are the operating modes of 8251. So actually what is the difference between parallel communication interface and serial communication interface? So for example, in parallel communication interface, it will contain more number of wires or more number of connecting buses, but for serial communication interface, it contains single line. That single line is enough to transfer the data from one device to the another device. That is what for serial transmission, that is bit by bit. So that is nothing but as serial communication interface. So let us see the introduction. And basically 8251 is a USART, that is Universal Synchronous Asynchronous Receiver Transmitter. So it is for serial data communication. So this peripheral, that is what this hardware device, that hardware device is mainly designed for the synchronous and asynchronous serial data communication. So it contains 28 pins, 28 pin DIP, that is dual inline package. So actually it will done the two different types of function. So at first it will receive the parallel data from the CPU, that is nothing but as from the microprocessor. Okay, it will receive the parallel data from the CPU and transmit the data and transmit the serial data after conversion. Okay, and it also receives serial data from the outside and transmits parallel data to the CPU after conversion. Okay, so it will do two different types of operation, that is serial to parallel converter and then parallel to serial converter or conversion. So let us see the block diagram. So before block diagram, we will see the pin diagram. So this is the pin diagram of 8251. So this IC contains 28 pins. The first pin is D2, second pin is D3. So it will contain 8 data bus. That data bus is your bidirectional data bus, that is D0 to D7, and here the third pin is RxD, that is received data. So first we will see the expansion of the pin. After that we will discuss the description of each and every pin in the IC 8251. Okay, so G and D ground, and 9th pin is TXE transmitter clock, 10th pin is write, 11th one CS chip selection, and 12th one is C/D bar, that is control and data, and RD is a read signal, and 14th one is RxRDY, that is receiver ready, and 28 D1, 27 D0. So 26th pin is VCC power supply, 25th RXE, that is receiver clock, and 24th DTR, that is data terminal ready, RTS request to send, DSR dataset ready, reset, clock, TXT stands for transmitter data, TXMT stands for transmitter empty, CTS is nothing but as clear to send, 16th pin is SYNDET, that is synchronous detection / break detection, and 15th one is TXRDY, that is transmitter ready. So 8251 is a universal synchronous asynchronous receiver and transmitter, and this IC will convert the parallel data into the serial stream of bits, and it is able to receive a serial stream of bits and convert it into parallel data bytes to be read by a microprocessor. Okay, so this is the basic definition of IC8251. So let me see the signals of 8251. So CS is chip selection signal. So actually this signal is when the signal is goes low, the 8251 is selected by the microprocessor unit for the communication. So that is a function actually. And then C/D control and data. So this signal having two condition. So when the signal is high, it will select the control or status register, and at the same time when the signal is low, it will select the data, that is data buffer. And coming to the write signal, actually write is a active low input signal. So it is used to writing the data and control words from the CPU into the 8251. Okay, so and reset. So reset is actually it is a reset signal which is used to reset the previous value. And next one, clock, that is clock input signal. So see the pin diagram. So the important pin C/D, 12th pin. Okay, so this pin will decide the operation. Okay, either the 8251 is accessed by the CPU, is accessed by the control or data. Actually this C/D is your input terminal which receives your signal for selecting data or command words and status. Okay, so D for status and C is command words and status. So when this signal is low, data will be accessed. At the same time, when this signal is high, command word or status will be accessed. Okay, so that is the important pin C/D. And and in this diagram, next pin is TXT, that is what transmitted data. So all of you see the pin 19th pin is TXD, transmitting data. So it is a output terminal actually. So this terminal for transmitting the data from which serial converted data is sent out. Okay, so the serial converted data is sent out by using TXD pin. And next one is TX/RDY. So now we are saying about the signals of the transmitter, and then we will discuss about the signals of the receiver. Okay, so the first signals of the transmitter is TXD, that is transmitting data, and next we are going to discuss about TX/RDY, that is transmitter ready. Actually it is a output terminal. This signal which used to indicate the 8251 is ready to accept your transmitted data character. Okay, that is the function of this pin, transmitter ready. That is what this signal shows the transmitter is ready to receive a data, ready to send a data. And the next transmitter signal is TXC, that is nothing but as transmitter clock. So TXC stands for transmitter clock. So actually this is the input terminal. So this clock input signal which determines the transfer speed of the transmitted data. Okay, so it will determine the transfer speed. So these three signals belongs from transmitter. Okay, the first one is TXD, TX/RDY and TXC. Okay, next we are going to discuss about the signals of the receiver. So let us see the first signal, RxD. So the RxD pin, that is the third pin. It is a terminal which receives the serial data. Actually it is your input terminal or input pin. Okay, and next one is RxRDY. See the 14th pin. So the 14th pin is RxRDY. This 14th pin, this RxRDY is a output terminal actually. So this pin will indicate that the 8251 contains a character that is ready to read. So that is the receiver is ready to read the data. So that is the pin. Actually it is the output terminal. And last pin is RxC. See the 25th. So RxC is the receiver clock. Actually it is a input terminal. Okay, as the same, this pin which determines the transfer speed of the received data. So it is same as the TXC. Okay, so these three are called as receiver signals of receiver. Okay, so for transmitter TXE, TXD, TXRDY, TXE, and last one is TXMT, right? So transmitter empty. So when there is no data is for transmission, when the transmitter is empty, that signal which it goes to high condition. Okay, that signal will shows the status of the transmitter, that is TXMT. And next we are going to discuss about the pin SYNDET. So 16th pin, that is what? Synchronous detection slash break detection. Actually, this pin which will be act in the two different mode. One is for synchronous mode and another one is for the asynchronous mode. Actually, when this pin is high, it will act as the internal synchronous mode. Actually, this pin, when this pin is low, it will act as the asynchronous mode. Okay, so that's the function of synchronous detection slash break detection. So let us see the four different types of modem control signal. Okay, so actually there are four modem control signals in the serial communication interface. So I will tell one by one. So first one is DSR. So DSR, where's DSR? So DSR in the 22nd pin, that is data set ready, and DTR 24th pin, data terminal ready, and 17th pin CTS clear to send, and 23rd pin RTS request to send. So these four pins are called as modem control signals. These signals are also called as handshaking signals. So first we will discuss about DSR, data set ready. So actually it is your input signal, input terminal. So it is your input port of the modem interface. So this signal will shows the input status of the terminal, can be recognized by the CPU reading status words, and DTR, that is data terminal ready. Okay, so here the terminal is nothing but as the receiver actually. So this signal is the output terminal. So this is an output port for the modem interface. And next one is CTS, that is what? Clear to send. So it is your input terminal for modem interface, which is used for controlling your transmit circuit, and RTS is nothing but as request to send. So actually it is your output terminal. So this output port for the modem interface. So that's all the description of the pin diagram of IC 8251, that is serial communication interface, or USART, that is universal synchronous asynchronous receiver transmitter. And next we are going to discuss about the block diagram of 8251. So let me see the blocks. So the first block is data bus buffer, and next one is read write control logic, and third one modem control. Here in the right hand side, transmit buffer is there. So this block will do the parallel to serial conversion, and transmit control, receive buffer. So this block will do the serial to parallel conversion, and finally receive control. So this is the blocks which are present in the 8251A. So now we are going to discuss about the blocks of 8251A. Okay, sorry, 8251 or 8251A. So both are same. So at first, data bus buffer. So the data bus buffer, the input of data bus buffer is D0 to D7. That is data bus which are in the bidirectional in manner. Okay, so this data bus will be used for read or write status, command word, or data from or to the 8251A. So it will done the dual process, that is what it can be able to send the data as well as receive the data, command word or data word. And next one is read write control logic. So for this read write control logic, it having 6 input. The inputs are reset input, clock, C/T, and write signal, and chip selection signal. And next, third block is modem control. So the modem control will done the handshaking process. So this block, which is mainly used for transmitting or receiving the data. So these are the 4 signal DSR. So I already explained about this 4 signal. So see, the DSR is data set ready. So it check if the data set is ready. So with when communicating with your modem and data terminal ready, so it will indicate that the device is ready to accept the data, and CTS clear to send, and RTS is request to send. So these four are called as the modem control signal. And see here, this is the transmitter section, guys. For transmitter section, it have three signals. That is what transmitting signals. One is transmitting data, transmitter ready, and then transmitter empty. So this signal will done the process of parallel to serial conversion. So see, it will accept the parallel data from the microprocessor and it converts them into serial data. So it will done the parallel to serial conversion. Actually, it having two different types of register. One is buffer register and another one is output register. So the buffer register will store the 8-bit value, and the output register, it will store the final converted value, that is the serial data values. And this is the receiver section. So this block will turn the serial data into parallel conversion data. So the parallel converted data will be stored in the receiver section. So it also have two different types of register. The one is receiver input register and another one is buffer register. So the receiver input register will store the final parallel data value. The buffer register will store the temporary values. So RX, RDY, RXD, RXE, these are the corresponding signals of the receiver. And next we are going to discuss about the control register. Actually, control register is a 16-bit register. So mainly this register is used for control the values or control the characters which are present in the 8251. So here we are going to discuss about the two different types of word, mode word and then command word. So the mode word is nothing but as it will specify the general characteristics of the operation, such as a baud value, parity value and number of bits. For command word, it will enable the data transmission and the reception. And next register is status register. So the status register will be used to show the status of the 8251. And for data register, it is used as an input and output port when the C/D is low. So this I already explained, guys. When C/D is low, the data will be accessed. Okay. When the same pin is high, the command word or the status word will be accessed. Okay. Let us see the table. So let us see the table. The first column CS, that is chip selection. Second column C/D, that is command / data word. And third column is write. And fourth column is read. So basically read and write is a active low signal. And fifth column is operation. So see the first condition, when CS is 0, C/D is 0, write is 1 and read is 0. Okay, so the operation is the microprocessor unit reads data from data buffer. Okay, so here the read pin shows 0. Okay, if it is 0, the read is active. Okay, if write is 1, so there is no write operation actually. So see the C/D value, that is 0. Okay, if it is 0, the data will be accessed. So only the microprocessor read the data from data buffer. And next condition, CS is 0, C/D is 0, write is 0 and read is 1. Here the write operation is going to done. Okay, so write is 0 and here read is 1. So 1 is nothing but as high and 0 is nothing but as low. Okay, 1 is high and 0 is low. Okay, and write is 0 and read is 1. So here the microprocessor unit writes data from data buffer. Okay, so here the writing operation is done. And third condition, CS is 0, C/D is 1, write is 0 and read is 1. So here the same writing operation is done, but C/D is 1. Okay, so this pin is high. Okay, when this C/D pin is high, the command or status word will be accessed. Actually, that is the condition. So see, the microprocessor writes a word to control register. Okay, so that is the important point. At the same time, see the fourth condition, when CS is 0, C/D is 1 and write is 1. Here and read is 0. Here the read operation is going to done, but the C/D is high. So when it is high, it will access the command or status register. See, the operation is the microprocessor unit reads a word from the status register. Okay, and the final condition is 1. There is CS is, if CS is 1, so the chip is not selected for any operation. So this is the table. So when the 4 CS C/D write and read conditions. So that's all about the explanation of the 8251, guys. So in this video we discussed about what is meant by serial communication interface and the pin diagram, block diagram, and then some different types of registers. Okay, so in next video we are going to discuss about the operating modes. Okay, the operating modes of 8251 actually. So basically it have two different operating modes: synchronous operating mode and then asynchronous operating mode. So that is what synchronous transmission and then asynchronous transmission. Okay, thank you.